All right, welcome to The Explainer. Today we're jumping into a book I absolutely love, Bill Bryson's A Short History of Nearly Everything. And we're not just going to cover what we know about the universe. No, we're going to get into the incredible, sometimes just plain bizarre story of how we actually figured it all out.
So Bryson starts with what he thinks is the single greatest miracle of them all, your own existence. I mean, think about that quote for a second. It's this idea that is so profound, it's actually kind of easy to just overlook. But the fact that trillions of atoms, trillions, somehow decided to come together in just the right way to make you, well, that's the absolute foundation of this entire story.
I mean, just think about it. Your life is this arrangement, right? It's so specialized, so particular, it has never been tried before, and it will only happen this one time. And what's it built from? Trillions of tiny, mindless particles that on their own aren't even alive. It's wild. If you could somehow pick yourself apart atom by atom, you just have a pile of fine dust. Dust that was once you. And none of those individual bits were ever alive. And yet, for the brief time you're here, they all just work together to make you, you.
So if your very existence is such an improbable wonder, how in the world did we humans ever figure out the story of everything else? That's the big question that really captivated Bryson, and it's the one we're going to dig into today. How do we know what we know? How do we figure out how old the Earth is, or what stars are made of, or, as we're about to see, how to hear the echo of creation itself? Okay, so our journey starts at the beginning. The very beginning of the universe. And it's a fantastic story about a couple of young astronomers who, well, they found something way, way bigger than they were looking for. Okay, so these guys, Penzias and Wilson, they're trying to use this massive antenna that belongs to Bell Labs, but they have a problem. They're being driven nuts by this unrelenting background noise. It was this steady hiss coming from every single point in the sky, day and night. It made any real work totally impossible, and they had no clue what it was, but man, were they determined to get rid of it.
And I mean for an entire year, they did everything you could possibly think of to kill that noise. They were absolutely convinced the problem had to be something boring, something physical they could find and just fix. They checked every electrical system, they rebuilt their instruments, they probably wiggled every single wire they could get their hands on.
And their dedication, it was next level. I mean, they even climbed into the giant dish to scrub off what they politely called white dielectric material, which, let's be honest, is just a fancy way of saying bird droppings. That just goes to show you how certain they were that the problem was something totally ordinary, something right here on Earth. But even after all that scrubbing, the hiss was still there.
So it turns out that annoying hiss? Yeah, it wasn't a faulty wire, and it definitely wasn't bird droppings. It was the afterglow of creation itself. Penzias and Wilson had, completely by accident, stumbled upon the cosmic microwave background radiation. We're talking about the oldest light in the entire universe, light that had traveled for billions and billions of years, only to end its journey as a faint hiss in their antenna in New Jersey. Wow.
Okay, but wait, that brings up a huge puzzle. The Big Bang, it only created the super light stuff. Hydrogen, helium, a tiny bit of lithium. So where did all the heavier elements come from? The stuff that actually makes us. The carbon in our cells, the oxygen we breathe, the iron in our blood. Where did that stuff come from? And for a long time, that was a huge hole in the whole theory. See, to make heavier elements, you need the kind of unbelievable heat and energy you'd find in a Big Bang. But there was only one of those, right? The answer, it turns out, wasn't at the beginning of the universe. It was in the absolutely spectacular death of giant stars.
Yeah, we're talking about a supernova, an explosion on a scale that is just unimaginable. I love how Bill Bryson puts it. It's like a trillion hydrogen bombs going off at once. It's an event so powerful it can literally outshine its entire home galaxy. That's the kind of power you need to cook up new elements.
And here's the ironic part. The guy who figured this all out, a cosmologist named Fred Hoyle, he actually hated the Big Bang Theory. In fact, he's the one who came up with the name Big Bang. He said it on a radio show as a way to make fun of the idea. But it was Hoyle who realized that in the crazy heat of these star explosions, we're talking over 100 million degrees, new, heavier elements could be forged. And then, these dying stars just blast those elements out into space, seeding the cosmos with the raw materials for everything else.
So the amazing takeaway from all this is we are literally made of stardust. The carbon in your cells, the nitrogen in your DNA, the calcium in your bones, the iron in your blood, all of it,
Every single atom that came together to make you once traveled across the entire galaxy from the fiery heart of an exploding star. How cool is that?
All right, so let's zoom in a bit, from the vastness of the cosmos right down to the ground beneath our feet, because this next puzzle is one that always amazed Bryson. How on earth did anyone ever figure out how much our planet weighs?
Yeah, and this wasn't some single, neat discovery. Not at all. This was a long, incredibly difficult process that spanned generations. I mean, just look at this timeline. You've got Richard Norwood in the 1600s, literally marching 208 miles with a chain. You've got a French expedition spending a grueling decade in the Andes Mountains. This whole story is just filled with brilliant, dedicated, and yeah, often very eccentric people, all pushing the limits of what was even possible.
So the person who finally put the last piece of the puzzle in place was a man named Henry Cavendish. Now Cavendish was, well, he was arguably the most gifted English scientist of his time, a total genius who was making discoveries that were a century ahead of everyone else. But he was also pathologically, almost cripplingly shy.
And when I say shy, I mean human contact was a source of just deep discomfort for him. There's a story that he once literally fled his own house just because an admirer showed up on his doorstep. He would only talk to his female housekeeper by leaving written notes for her. He just avoided people at all costs. He much preferred the silent company of his experiments, which he conducted in this massive private laboratory he built inside his own mansion.
And it was right there, in that private lab, in 1797, that Cavendish built this really ingenious device. It was all lead balls and wires, and his goal was to measure the incredibly tiny gravitational pull between them. See, if he could calculate that force, he could figure out a magic number we now call the universal gravitational constant, or G. And with that number, for the very first time in history, anyone could calculate the mass of the entire planet.
Before Cavendish, the best guess came from weighing a mountain in Scotland. It put the Earth at about 5 quadrillion tons. But Cavendish's experiment gave science the key, that G number, to calculate this colossal figure with incredible precision, getting it super close to the modern value of just under 6 quadrillion tons. And the most amazing part? He did it all with careful, quiet measurements in a single room.
And really, that's what Bill Bryson's book leaves you with, this feeling of awe. Through all of these strange, brilliant, and sometimes just plain accidental discoveries, we've managed to figure out so much. But the real takeaway isn't just a list of facts, right? It's this sense of profound, limitless wonder. Wonder at the universe, sure, but also wonder at our own improbable ability to actually understand a little piece of it.